With binary numbers, we can store values that we would ordinarily represent in decimal in a format that the computer can store, send, or receive. But as we think about values, the more digits that are in the number, the larger the value can be. So let's take this binary number, 10. This is a 2-bit digit, meaning that it contains 2 digits, each one being a bit, a 1 or a 0. This 2-bit number can store 4 different values and has a maximum value of 3. As we add additional digits, we increase the maximum value we can store in that binary number. Have you heard the term 8-bit? 8-bit, 16-bit, 32-bit, 64-bit, and higher, these are all representations of the number of digits that are available to store in a binary number. If we look at an 8-bit number, we have 8 columns, or 8 possible digits. If we do the math for each column, we can store a maximum value of 255. If we add 0, which is a value of nothing, we can store a total of 256 values, from 0 to 255. And what is 2 to the 8th power? It's 256. But 256 is not a very high number. So if we need to store a larger number, we need more bits. If we add more to make a 16-bit number, we can store up to a value of 65,535, or 65,536 values, including 0. Need more? Let's double it to 32-bit. Now we can store 4,294,967,296 values. 64-bit can store over 18 quintillion values, and the number gets larger and larger the more bits we add. Using these bits, a computer program can store values in memory. A programmer needs to balance the storage requirements of their applications to the amount that is available for the program. To help manage that, developers have different sizes and types of containers called variables that they can use to store information. Each variable type has a different bit size requirement, meaning that the variable has a limited size that the programmer can store values into. For example, a programmer might use a variable type that requires a single byte. That byte contains 8 bits, so we can store values from 0 to 255. It can only contain those values, and it can only contain whole numbers, meaning it can't carry a decimal. But 255 isn't that much, so there are larger and larger types that programmers can use to store values. Each larger type reserves a different number of bits in the computer's memory. A larger container that uses 32 bits can store a bigger number, in this case a number as high as 4 billion. But what about negative numbers? When we write a negative number like -5, we need to put a minus sign before the number. This sign needs to be captured as data for the computer to understand. So to store that sign, a bit is reserved for whether the number is positive or negative. This creates a signed number. But in a 32-bit value, since we lose 1 bit for the sign, we can only use 31 bits to store the number. So the largest value we can store is smaller. As a result, with 31 bits, we can only store a value of just over 2 billion. But with the bit used for the positive or negative sign, we have the same range as a number without a sign. A programmer can easily store one or a few of these values without worrying about numbers. What about something like a spreadsheet? Let's assume a single cell can store a value using 64 bits. That's a number that can hold a lot of information, and we can easily store positive, negative, and even decimal numbers for us to do calculations with. 64 bits is equal to 8 bytes. So that seems harmless enough, but a spreadsheet can contain tons of data in it. In fact, Excel spreadsheets can contain over 1 million rows and more than 16,000 columns. That's over 17 billion cells of data. With each one requiring 8 bytes, that's 137,438,953,472 bytes, or 128 gigabytes of storage. Yikes! Luckily, programmers and computers have ways to compress and reduce the amount of memory that files and programs like spreadsheets have to take. but you can see how you can quickly consume a lot of memory. So while it might seem like a computer can handle all the data you throw at it, it's not quite that simple. When a developer has to limit themselves to the available memory on a phone, which could be only 1 or 2 gigabytes, with a lot of that already used by the operating system, a lot of care needs to be taken in how to use the memory that is available and to avoid slowing down the system by taking up too much space.